Hello everyone, very good evening. I welcome you all at India's most comprehensive preparation platform for all competitive exams, that is BYJU'S Exam Prep. So guys, today we are going to discuss some important concepts of SQL. Okay, so let's move further. My name is Vishal Rawatiya. I have 10 plus years of teaching experience. These are the achievements and areas of expertise. Now, let's move to the topic that what is the most important topic in the structured query language, and that is what we are going to discuss in the today's session. So today we will learn the concept of nested SQL query. What is the important? So let's try to understand that these are some questions which are from the last 2-3 years related to the same concept which we are going to discuss in the today's session. So first of all, let's check whether you are able to solve this type of questions or not. And if not, then we will first understand the concept related to this type of questions, and that at 10:15 p.m. we will discuss all these questions at the application. So let's start. So this is one question. So let's try to understand that this is something in which there is a nested query. That this is a query, select query, and inside the query there is another query. So whether you are able to solve this type of questions or not, that's what we are going to discuss in the today's session, and we will also solve all these questions. So again, this is another query, and then we are saying that this is another query which is inside this query. So another query is being executed to solve the original query, and that's the concept of nested query. So these two queries are basically independent nested query, and this is the concept of correlated nested query, in which this is the outer relation, this is your outer query, and inside the query the attribute is specified. This S number is actually the attribute. This S.S number is the attribute from this outside relation S. So this is being used in the inside query. So we'll understand the difference between independent nested query as well as correlated nested query, and we will see that how we can solve such type of questions. And this is a very easy topic. The only problem is that people do not understand the order of execution of an correlated query, and they give the wrong answer for the questions. So let's try to understand first, which is most important with respect to SQL, that in what order the different clauses of SQL are evaluated in general. If it is a normal, not a nested query, it is a single query, then in what order the query will be evaluated. So first of all, you will take so this is from, that is from what relation. So first of all, you will take the tuples from the relation which is specified with the from clause. Then you will go into the where clause and you will evaluate the where condition. If the where condition is true, then that particular tuple will be selected. Now, based on all the tuples which are selected, which are selected, you will group them based on the group by clause. And if at all a having condition is applied on the group, then you will again select the groups out of those groups which are satisfying the having condition. Then whatever groups are satisfying the having condition, those groups will be selected, and from that these attributes specified in the select clause will be projected, right? So this select in SQL is actually equivalent to project of relational algebra. So it may look project of relational algebra, whereas this where of SQL is equivalent to select of relational algebra. So don't get confused. Where in SQL is equivalent to select clause of relational algebra, and select clause of SQL is actually equivalent to the project of relational algebra. So this is the normal execution order. From a relation, a tuple will be selected, then we'll apply the where condition. Then from all the tuples which are selected, we will group them based on the group by clause. Then we'll see whether the given group are satisfying the condition specified by the having clause or not. If satisfied, then from those selected tuples will project the attributes which are defined in the select clause, and finally the output will be available in the form of an order if we are using the order by clause. Clear? Is this clear to everybody? Let's move ahead. So first try to understand that why do we need nested query. So let's try to give the answer for this particular example. So consider that we have a relational schema in which the student is the table. It consists of three attributes: SID, name of the student, and the marks of the student. If I ask you to write the SQL query to retrieve SID of the student who scored maximum marks, what will you do? What will you do? So there are certain things which you need to understand first. What? Sir, where clause is applied on each tuple. Of the relation applied on each tuple, whereas this having clause is applied on each group. So when you say it is applied on each group, then is it necessary that group by clause must be present if you are using the having clause? No. You can have having clause without group by clause, but in that particular case, the having clause will degenerate into where clause. What does it mean? That the condition of the having clause will be applied on each tuple of the relation. Clear? So that's the idea of this. Now, if you try to give the answer for this, then you all must know that there are some aggregate operations. There are some aggregate operations in the relation SQL. So there's an aggregate operation known as max, which can give you the maximum value of a particular attribute. But if you guys don't know the concept of nested query, then you may eventually try to give the answer for this particular query as, I'll be writing select. So what do we need to project? We need to project the SID. So select SID from where? From the relation student. From relation student, where marks of that student are actually equal to the maximum of the marks. Now tell me, is this a correct query? That's the very first question. If any one of you is trying to give the answer for this particular question in the form of this query, then the very first thing to ask is that, is this a correct query? What will happen if we apply this query on this relational table student? What will happen? Give me two answers. Give me two answers. The first question is that, is this a correct query? And if it is not a correct query, then what will be the output of this? What will be the output of this? Is this a correct query? Guys, please answer. So, okay. So, the idea is that this is not a correct query. Why? Because this where condition will be applied. This where condition will be applied on each tuple. So, when you say marks equals to maximum marks, then this aggregate operation, maximum marks, will be applied on each tuple. If at all it is executed, then this aggregate operation, maximum marks, will be applied on each tuple, and for a tuple, maximum marks will be the marks of the tuple itself. For a tuple, if this aggregate operation is applied, being applied on a single tuple, then the maximum marks will be the marks of that particular tuple itself. Therefore, if at all this is executed, either it will produce an error. So there are different databases query processor. So in some processor, it will eventually produce an error. If at all, if it is executed, then all the SIDs of the student table will be projected. Okay. So what will be the correct query then? What will be the correct query? If it is not a correct query, what will be the correct query? Sir, you will have to write something like this. Select SID from the table student where marks are actually equal to the maximum of the marks in the student table. Marks are actually equal to the maximum of the marks in the student table. So what will you do? This should be equal to another query, which is select max of marks from the student. So are you getting the idea that this, if for each tuple, first of all this inner query will be evaluated. This inner query will eventually provide the maximum marks in the student table. This inner query will provide the maximum marks among all the tuples in the student table, and that maximum mark will be compared with the marks of that particular tuple. So for whichever tuple the marks in that particular tuple are equal to the maximum marks in the student table, that particular tuple will be selected, and the SID from that particular tuple will be projected. Clear? So that's the idea, and this is the concept of nested query. So what is this? This is nested query. This is our nested query, right? So, sir, can this query be executed independently? Yes, sir. Let's try to understand. If we do not write this thing, if we do not write this outer query, then also can we execute this query? Yes. So this query, which is a inner query, can be executed independently. It is not dependent on the outer query. So because this inner query is not dependent on the outer query, we call it as a independent nested query. If the inner query uses the attribute specified by the outer relation, then it will be known as correlated query. So there will be two types of nested queries. Which we need to discuss. One is the independent nested query, another is the correlated nested queries. And from both the topics, the questions have been asked in the GATE exam very frequently. So if you look at the papers from last 5 years, then every year you will get the question from one of these two particular thing, or either the similar concept will be asked in the terms of relational algebra, right? So this is very important that you understand these two types of query, because if you don't know this, then somehow you have lost your 2 marks in the GATE exam, right? So what is important? So let's try to understand. What is independent nested query? When do we say that a query is independent nested query? So we say that the query is independent nested query when inner query is independent of outer query. I'll explain both the types of query all together. So, example, previous slide, whatever we have discussed on the previous slide is the example of independent nested query, because in the previous slide, the query can eventually be executed independently. It is not dependent on the outer query. That's the first thing. So, sir, if this type of queries are independent query, then what do you mean by correlated queries? So we will discuss two things all together. So what is this? Inner query. What happens in the correlated query? Inner query uses the attribute specified in the outer relation. It uses the attribute specified in the outer relation. So let me try to give the example of this particular thing. So you can say select, and this is most important. So please watch it carefully because this is most important thing in the terms of SQL. If you don't know this, then perhaps you have lost your 2 marks. So select, let's assume that the inner relation or the outside relation is relation R. So let's say from R. So this is your relation. This is your name of relation. So from this relation R, you are trying to select the attribute A. Okay, so this A is nothing but your attribute. So select some R dot A from relation R, where there will be something where, and then you will have an inner query, select whatever, we don't know. I mean, it's not necessary that what you are selecting, but the idea is select, where now to execute this where condition, you are, sorry, too fast. Select this from some other relation. Let's say the inner query uses some other relation S. Select asterisk from the relation S. But here a where condition is being applied, where some attribute B of S is actually equal to some attribute C, or I mean this C can be any attribute. This C can be any attribute from the relation R. It's not necessarily attribute which is being projected in the outer query, or not necessarily the attribute with which it is being compared. It can be anything. It can be anything. So let's try to understand that, okay, such type of queries will be known as correlated query, in which you cannot execute this inner query independently, because this inner query actually requires something which is specified in the outer relation. This inner query requires something which is specified in the outer relation. Have you got the idea? So if it is completely on the relation S, then perhaps we may execute it independently. But here, if it is using something which is available in the relation which is corresponding to the outer query, then this inner query cannot be executed independently. So that's the difference, that when inner query is independent of outer query, we call it independent nested query. What will be the order of execution? What will be the order of execution? So whenever an independent nested query needs to be executed, first of all you will execute inner query. So inner query will be executed first, and based on the output of that inner query, you will eventually execute the outer query. But here in this particular type of query, what will be the order of execution? Or order of evaluation. If you have understood this order, then you have understood the concept of correlated nested query. This is all what you need to understand. So let's try to realize that what will be the order of evaluation. So first of all, what will happen? The very first thing is, from relation R, first you will take a tuple from relation R. So this is the first thing that will happen. First, you will take a tuple from relation R. With that tuple, you will go to the inner relation. Then you will take a tuple from relation S. So in the tuple of relation R, you will have the information about this attribute C. You have taken the complete tuple. So in that complete tuple, you will also have the information of attribute C, and you have the tuple from the inner relation. So from this inner relation, you have the information of this attribute B. So then the next thing that will happen is that you will execute this where condition based on the information of attribute A, attribute C available in the tuple of relation R and the information of attribute B available in the tuple of relation S. Now, if this where condition is true, then that particular tuple will be selected. If that particular condition is not true, then that particular tuple will not be selected. Now, this will be the third thing, that okay, based on that you will select things. Sorry, fourth. Something else will happen at this point of time. And this is very important. So, sir, or let me write it here. 2, 3 and B, after where you will select, Now what will happen? These three steps will be performed for the complete relation S with respect to the first tuple of relation R. So, 2, 3 and 4 will be performed or will be executed on all the tuples, I would say, on all the tuples of relation S with respect to every tuple of relation R. So what will happen when you have scanned the complete table S with respect to this first tuple of R, you will eventually provide the output of this where clause. That okay, what is the output of inner table? What is the output of inner table, not the tuple? What is the output of inner table with respect to first tuple of relation R? Based on that, the where condition will produce its output. Either where condition will be true or where condition will be false. If the where condition is true, then the attribute A from that particular tuple will be selected. If where condition is false, then attribute A from that first tuple will not be selected. So this is the order of evaluation. It is very important. First, you will take one tuple from relation R. You will scan the complete inner table with respect to first tuple. Based on that, you will provide whether the where condition is true or false. And based on that, you will either select the attribute A from that first tuple or you will not select the attribute A from that first tuple. Similarly, once we are done with the first tuple of relation R, we will choose the second tuple of relation R. Then we will again process the this inner query on the complete inner relation with respect to second tuple of the relation R, and then again the where condition will produce its output either true or false, and based on that the selection will be performed from the second tuple with respect to second tuple. So we will understand that this particular concept with the help of an example, but for time being let it be. So what happened? So, what will happen in the inner query? Inner query will be executed first, and based on the output of inner query, you will eventually produce the output of outer query. But here, inner query and outer query will execute in the recursive manner. That is first tuple of outer relation and the complete inner table. Then the second tuple of outer relation, then the complete inner table. Then the third tuple of outer relation, then the complete inner table, and so on. So for each tuple of outer relation, you will scan the complete inner table, and then only you will be able to produce the output of correlated query. Right? Now, there will be some operators which will be used with respect to independent nested queries, and there will be some operators which will be used with respect to correlated nested queries. So it is not so that the operators which are being specified with respect to independent nested query cannot be used with correlated, or the operators which are being defined with respect to correlated nested query cannot be used with independent nested query, but in general they will be used in the specific manner only. So best used operators with respect to independent nested query are in, any, and all. So these are the operators which will be generally used with independent nested queries, whereas the operator which will be used with respect to correlated nested query will be exist. Operator used is exist, right? And how they eventually produce their output, that's also we need to understand. So now for time being, I'll take just 5 minutes to explain all these operators, and then we'll try to understand the example. So what do I mean by in operator? So let's see, in operator is used to check whether the tuple being checked is a member of set of tuples or not, is a member of set of tuples or not. This is what it does. So let's try to understand with example. Check x in. So this is a particular tuple. So for our understanding, we are looking that okay, x is a single value, but just try to understand that all the tuples are the element. So the complete table is a set, and each tuple of that relation is the elements of that set. The complete table is a set, and each tuple of that table is the elements of that set. So you are actually trying to say x in, let's assume a set of tuple is 2, 4, 7, 8, 10. Yes or no? So this is something like this. So if x is equals to 4, tell me, if x is equals to 4, then 4 is in this set of tuples or not? Yes sir, 4 is in this set of tuples. Therefore, if x equals to 4, then in returns true. Okay, so if it is a member of the given set of tuples, then it is true. Then in returns true. Right? If let's assume x equals to 6. So is 6 is a member of this set of tuple? No sir, 6 is not a member of this set of tuples. Therefore, if x equals to 6, then in returns false. Corresponding to this given example, I mean, this can be performed based on any table. So whether a tuple is a member of the set of tuples or not. So this set of tuples will be a relation actually, and this tuple will be a single tuple from some other relation or from that relation only. So it may be from anywhere, right? So this is the idea. So what will be the complement of in? So if you want to check in, then obviously there will be a complement of in as well. So complement of in is not in. Complement of in is not in. Right? So yeah, fine. I'll give you the example all together. First, try to understand the operators. So this is in operator. So this is a simple operator. So it is basically checking whether your tuple is a member of the given set of tuples or not. Right? So next one is any operator. So what happens with the any operator? Any does not work alone. Any operator is used along with other comparison operator. So just note down. Any operator is used along with other comparison operator. That is, what are the comparison operator? So less than equals to, greater than equals to, or simply equals to, and not equals to. So this is not equals to, right? So let's assume if I say example, x equals to any, or yeah, x equals to any. So this is your operator, x equals to any in this set. Let's assume 2, 4, 5, 7, 9. So what will happen if x equals to 5? If x equals to 5, what will be the output of any? If x equals to 5, any will return true because it is equals to, is x, or the x is 5 equals to any of this element? Is 5 equals to any of the element of this set? Yes, sir. So equals to any returns true. So do you realize one thing, that equals to any and in are exactly same? So we can actually say that in operator is actually equivalent to equals to any. So there is no difference between in operator and equals to any operator. They perform the same task, whether x is in the set of tuples or not, or x is equals to any of the member of this tuples or not, right? So this one thing. Now if I say that okay, the operation can be anything else. So this example, x less than any, x less than any of this 3, 4, 5, 7, 9. So if x equals to 10, what will be the output? Is 10 less than any of these members of this tuple? No, sir. 10 is not less than any of the member of this set of tuples. Therefore, less than any returns true. Oh, sorry, false. If x equals to, let's assume 6. So is 6 less than any of the element of this set? So 6 is not less than 3, so it will keep checking. 6 is not less than 4, so it will move to the next element. 6 is not less than 5, so it will move to the next element. Then 6 is less than 6. So the moment it identifies that yes, 6 is less than any of this element, then it will not check for the remaining element. Then it will not check for the remaining element. So if x less than equals to, if x or 6 is less than equals to any of this element, yes, therefore any returns true. So tell me, if this set of tuple is empty, what will be the output of any if set of tuple, if this set of tuple is empty, then any always returns false. Clear? This is the scenario. So if this set of tuples is empty, then any will always return false, because for any to return true, at least one of the tuple of this set should satisfy this comparison condition. For any to return true, at least one of the element of this set should satisfy the comparison condition. If there is no element in this set, then there is no one to satisfy the comparison condition, and in that case any will return false. Clear? So this is the idea. Next, move to the all operator. So all is also exactly same, that it will also be used along with other comparison operator. All is also used along with other comparison operator. So let's take an example. So x less than all, and the set of tuple is 2, 4, 5, 7, 9. If this is the scenario, if x less than all of this, if I say if x equals to 5, so is 5 less than all the elements of this set? Is 5 less than all the elements of this set? No, sir. If any of the tuple of this set of tuples fails the comparison condition, so it will check 5 less than 2. No. So the moment it checks that 5 is not less than 2, eventually all will return false. That if any of the tuple of this set of tuples fails this comparison condition, then all will return false. All returns false. Similarly, if x equals to 0, what will be the output? If x equals to 0, so 0 less than 2, yes. 0 less than 4, yes. 0 less than 5, yes. 0 less than 7, yes. 0 less than 9, yes. So no tuple of this set of tuple failed the comparison condition, therefore all returns true. Now, my question is, what will be the output of all? What will be the output of all if this set of tuple is empty? Tell me, what will be the output of all? All will return true or false? All will return true or false. So what's the idea? All will return false if any of this tuple of the set of tuple fails the comparison condition. So if the set is empty, then there is no one to fail the comparison condition, and therefore all will return true. Therefore all always returns true. Got the idea? So this is something which you need to remember. If your given set of tuple is empty, then any will always return false. And if the set of tuple is empty, then all will always return true. Clear? So this is the simple thing. Now can I say not n? So n is equals to any. So not n will be equivalent to what? Not n will be equivalent to not equal to all. If the element is not equals to all of them, not equal to all of them, then not n will be true. So not n actually equivalent to not equals to all. Clear? So not n will return true when the element is not there, and not all will return true when the element is not there. Right? So let's see. If I say x not equals to all, and if I check for 1, so 1 not equals to 2, true. 1 not equals to 4, true. 1 not equals to 5, true. 1 not equals to 7, true. 1 not equals to, just a minute, sorry, not equals to any. Not equals to any, because this is not equals to all. So it's not possible that something is not equals to all of them. Clear? So this is it. So we have seen all three operators. In, it will just check whether it is a member or not. Equals to any will eventually be equivalent to in only, but any can also be used along with other operators. So it is not necessary that any is always or any is exactly like in. No, any can check for other comparison conditions as well. Therefore, there is a use of any as well. So we can actually say, so the in is actually redundant, because if you want to check for in, you can actually check equals to any. If you check for in, you can equal to check equals to any. Just a minute. Not in. I'm getting confused. Just a minute. Not in. Let's check. If I want to say x equals to 1, not in 2, 4, 5, 7, then not in will return true. Similarly, not equals to all of them, 2, 4, 5, 7. So not equals to all, 1 not equals to 2, true. 1 not equals to 4, true. 1 not equals to 5, true. So this will also return true. Yes, it will be not equals to all only. Why? Why? Not in is not equals to any. Why? Because in and not in are complement of each other. So if the set is empty, in will return false, but not in will return true. So if the set is empty, all can only return true, any will always return false. Therefore, it has to be equivalent to not equals to all. It has to be equivalent to not equals to all. Earlier I was right, then I thought of something else and got confused. Yeah, that's natural. Now, the next thing is exist operator. So this is very simple operator. It does not check for anything else. It only check for one thing, that your inner query result is empty or not empty. So what does it do? It only checks whether inner query result is empty or not empty. Inner query result is empty or not empty. So what if inner query result is not empty? If inner query result is not empty, then exist return true. Next, if inner query result is empty, then exist return false. What the idea? Okay, so this is simple. Now, what will be the complement of exist? Complement of exist is not exist. There are complements as well. So, if not exist is written, you may say, sir, it is not an operator. Yes, it is also operator. So, complement of exist is not exist. So when exist will return true, not exist will return false. When exist will return false, not exist will return true. Clear? So to understand this concept, let's try to consider, let us consider one example. So consider the following relational schema. What? One is the supplier table. which consists of the ID of supplier, name of the supplier, and the city of the supplier. Another is the part table, which includes the ID of the part, name of the part, and the color of that part. Catalog is eventually considering the information that which supplier has sold which particular part. SID and PID together are primary key. Therefore, one supplier cannot supply the same part at two different costs. Otherwise, S1 P1 the cost is, let's assume, 20. So for another S1 P1 cost cannot be 30. Otherwise, S1 P1 will not remain unique, right? So let's try to understand. I've just taken the instances. I've just taken the instances of this catalog that, okay, we are considering only SID and PID. We are not considering cost at this point of time. I have also taken one sub-relation from parts in which we are considering PID and color only. We are not considering this name. Now this is your query. Select C.SID. Select C.SID from catalog, which is renamed as C. So if you say catalog C, then eventually you can say catalog as C, or this is a new method, but earlier we simply used to write catalog space C. So catalog will be renamed in the form of C. Then what is the need of S then? So S can also alias your attributes, whereas this simple method cannot be used for the aliasing of the attribute. So as is more powerful. Okay, so what does it say? Select C.SID from catalog C where exists. So this is the operator which is being used. Exists. So if exists returns true, then the where condition will be true. If exists returns false, then where condition will be false. Got the idea? Now this is your inner query. Now tell me, the very first question is, tell me whether this inner query is independent nested query or correlated nested query. The very first thing, whether this inner query is independent nested query or correlated nested query. Give me the answer. Sir, to evaluate this where condition of inner query, we need the attribute PID from the relation S. That means it is using the attribute which is available in the outer relation. Therefore, it is correlated query. What type of query is this? Sir, it is correlated. Now, what will be the output? My question is, what will be the output if above query, or if the query is executed on the above instances of catalog and parts. This is my question. Try to execute this query if you have understood this order. Inner queries, independent nested query is simple. We'll just understand that with a single example. So you can already understand that from here as well, that okay, first it will be calculated, it will produce one output, that output will be calculated with the marks of every tuple. So that's simple. But here the order of execution will be different. So just remember, first take one tuple from relation, outer relation, then take first tuple from inner relation, then check for the where condition. Based on that, select choose whether that tuple will be selected or not. So that's the idea. Give me the answer. So let me explain the working, or you guys are trying. I'm giving you 1 minute time. So please try and give me the answer. Please try this query and give me the answer. Okay. It's fine. Let's start. So what will happen? What did I say? First, you will take the first tuple, that is S1 P1. Understand this. You will take the first tuple from the relation catalog, that is S1 P1. Then you will go to the inner table. What is inner table? Inner table consists of three tuples: P1, red, P2, green, P3, red. Now, what will happen? So, you will take the first tuple. So, then you will take the first tuple from the outer relation, then you will take the first tuple from the inner relation, that is P1 and red. So, this is your table P, this is your table C. Now, first you will check this condition. So, this is first, you have done, this is second, you have done. Now, go to the where condition. You will check P dot PID is equals to C dot PID or not. So, whatever is the PID in the P table, is it same as C dot PID? Yes, sir, these two PIDs are same. If it is true, then you will check the AND condition, that P dot color is equals to red or not. Yes, sir, in this comparison of tuple, P dot color is equals to red. Therefore, this where condition will be true. Where condition will be true. If where condition is true, then you will select, or this particular thing will be selected at this point of time. Let me give you the complete thing. So, this from what thing will be selected? Sir, this tuple from the part table will be selected. Yes or no? Because here we are selecting from what? Part table. We are selecting from what? We are selecting from part table. So, this tuple will be selected. You just need to understand one thing. If any of the tuple is selected, then this exists is guaranteed to return true with respect to this first tuple. Yes or no? Exists is guaranteed to return true, because if any of the tuple is present, then it cannot happen that because of execution or because of executions of other things, that particular tuple will be removed. No, tuples are only added as the query proceeds further. Right? Now what will happen? Then you will check this S1 P1 with the second tuple of the part, that is P2 and green. Now we will check whether this P dot PID is equals to C dot PID or not. So, it is not. So, it is false. Therefore, this where condition will be false, and this second tuple of the part table will not be selected. Then what will happen? Then you will take the first tuple of the part which is already there, and you will compare that with the third tuple of the part table. You will take the first tuple from catalog and you will compare it with the third tuple of the part, that is P3 red. Again, P dot PID is not equals to C dot PID, therefore it is also not selected. Now, we have checked the complete part table. We have checked the complete part table with respect to this first tuple of outer relation, that is for the first tuple, we know the output of inner query. For the first tuple, we know the output of inner query. Now, for the first tuple, the output of inner query is not empty. For the first tuple, the output of inner query is not empty. And because it is not empty, therefore, this where is true, and because where is true, therefore this first tuple S1 P1 will be selected. So, for time being, this S1 P1 is satisfying the condition. For time being, this S1 P1 is satisfying the condition. So, there will be one thing which will be created with respect to S1 P1. Now, what will happen? So, then we will have S2 P2. Then we will have S2 P2. Now, when S2 P2 will be compared with P1 red, when S2 P2 will be compared with P1 red, then what will happen? P dot PID is not equals to C dot PID, therefore not selected. P dot PID is equals to C dot PID, but color is not equals to red, therefore again not selected. P dot PID is not equals to C dot PID, therefore nothing is selected. So what will happen? With respect to second tuple of relation C, with respect to second tuple of relation C, we have checked the complete part table, and for the second tuple, of relation catalog, the inner query result is empty. Inner query result is empty. So with respect to this is false, this is false, this is false. So empty. And because empty, therefore exists will return false, and because it is false, this tuple will not be used for the further consideration. Now what will happen? Then you will have the third tuple, which is S3P3. You will have S3P3. Now with respect to this S3P3, what will happen? Sir, S3P3, P1 red will be false, P2 green will be false, but for this P3, is it visible here? Yes. For this P3, you will eventually have red. Now what will happen? Sir, these two are not selected, but P3 equals to P3 and color equals to red, therefore this will be selected. So because this is selected, again not empty. Again not empty, right? So if it is not empty, then exists will return true, and because where condition is true, therefore this is also being considered for the further calculation. Now, because of this where condition, these two tuples are chosen. Because of this where condition, these two tuples are chosen, and from this chosen tuple, because of this select clause, from this chosen tuples, you will select the SIDs, that is S1 will be selected and S3 will be selected. Therefore, the output of this particular query will be S1, S3. Got the idea? So, what is being produced by this particular query? So it is checking whether the supplier, so what is happening? Sir, P.PID equals to C.PID means whatever PID is available in the outer tuple, that is being checked in the inside table. So first we are checking that the part supplied by the supplier is of red color or not. If the part supplied by the supplier of red color, then that particular tuple will be selected and exists will not be false, exists will be true. So the SID of that particular tuple will be selected. So it is actually producing the SIDs of the suppliers who have supplied some red color parts. So if the supplier has supplied any red color part, then the SID of that particular supplier will be chosen. Clear? Have you understood the idea that how a correlated query will be executed? First tuple will be with respect to first tuple, you will process the complete inner query, and then only you will check whether the first tuple is chosen or not. Then for the second tuple, again you will process the complete inner relation, and then you will choose whether the second tuple is chosen or not. For the next tuple of the outer relation, you will process the complete inner relation and you will check whether the third tuple is chosen or not. And from those chosen tuples, whatever is being selected using the select clause, that particular thing will be projected. Clear? I hope this thing is clear to everybody. So we have understood the concept of independent nested query and correlated nested query. Now we will discuss those questions which I have shown you at the beginning of this particular session, but those questions will be discussed at the application. So this session at the application is absolutely free. You just need to register and you will be able to access this particular session. So please join now. In next 2 to 3 minutes, I'll start discussing all those questions on the application. So please join the session on the application. Okay.